It's like GB. Okay. So we'll try with this resolution. And we'll see. PE files for Pocket PC. I will start with the tools you need. Then, or you can dump PE files because it's different from Windows PC process dumping. Then, how you can find entry point of the original application. I will also present anti-debugging techniques on Pocket PC. And I will also give 2 examples. One of them is UPX, which is a free packer for PE files, and then some commercial protector. I won't give the name of the protection system just in case. And then I will do demonstrations. So we have seen a few malwares on Pocket PC in the past, but none of them were actually compressed or encrypted. And since most of the Windows PC malwares are encrypted, it might happen in the future that we have compressed or protected malwares for Pocket PC or smartphones. Anyway, there are a few compressors and protectors out there for Pocket PC. You have even free ones like UPX, so anyone can get UPX and compress their malwares. And UPX allows you to unpack the file, but you can easily patch the file so UPX doesn't uncompress it anymore. And there is nothing public regarding unpacking Pocket PC files, and there is no public dumpers to do it. So I'm going to give one after my talk. So the tools you need, you can use IDA Pocket PC debugger. For disassembling files, you can use IDA 2. There is no process dumper for now. And you can use file manipulation tools like NEP file editors, like LordPE, and hexadecimal editors. So, process dumping. The main problem when you want to dump Pocket PC is that there is no PE header in memory. So if you dump the application, you still don't have the PE header, and the file is not going to be loaded by the operating system. There is no public process dumper for Pocket PC. And you could write one, a native process dumper, but you don't need to do that. So how can you dump process on PC? You first use IDA debugger to find the original entry point. And then you can write an IDC script for dumping. Then you can, so the main problem is there is no headers in memory, so we can just use them from disk. And once we have the headers from disk, we can just append everything from memory to this header file. And then we need to fix the headers with things like we need to change the physical size to the virtual size and the physical offset to the size in memory for each section. And then you need to fix the import table for your files if you want it to be working or if you want to have a clean disassembly. Then the next point is finding the original point of the application. It's very similar to Windows PC. You can trace the whole application until you find the jump to the original entry point. You can use compiler signatures to find the entry point. This works very well because you don't need to bother with the anti-debugging tricks. You can just pass the memory when the application is being run, and you can quickly find the entry point using signatures. You can also use breakpoint on Windows on API functions, such as the ones used to load the imports, like get proc address, load library, or the ones used to flush the cache, like flush instruction cache or cache sync. Because in order to execute uncompressed code, the packer for Pocket PC needs to flush the cache, because if it doesn't flush the cache, it's going to execute compressed code or encrypted code. So usually they flush the cache just before jumping to the original entry point. So the anti-debugging techniques for Pocket PC, most tricks from Windows PC can be used to detect debugging. You can use timing execution to detect single stepping. You can use API functions to detect debuggers. There are a few functions inside core GLR. And you can use breakpoint detections and checksumming, things like this. But another very powerful technique is using the instruction cache to kill debuggers. Because as I said, Pocket PC use a ARM processor, and most of the time, and if you are trying to decrypt instructions before executing them, you need to flush the cache so you can actually execute this decrypted code. You will execute encrypted code otherwise. But one thing is debuggers will flush the cache for you anytime. So what you can do is you can just encrypt part of your loader with a random key or whatever. You can just modify parts of your code. And your packer is not going to flush the cache, so it's not going to be executed. But if someone is debugging this protection, then the debugger is going to flush the cache and you will end up calling garbage code. So this is a very nice feature of the Pocket PC processors. Unfortunately, there is no easy way to locate such anti-debugging tricks, because most of the time the loader is going to decrypt its own code anyway. So some of those packers have plenty of layers, so they will decrypt themselves a dozen times. And so they could just put an anti-debugger inside those layers. So you need to be careful when you are tracing every layers and trying to look for suspicious decryption or fake decryption. And once you have found this suspicious decrypting code or something that modifies the flow of the application, you can just skip it by changing the instruction pointer, the PC register, which is the same thing as the EI register for Intel processors. And then you can just keep tracing the loader. So a little example now, UPX. UPX now supports PE files for Pocket PC too. The way it works is very similar to Windows PC. The file is compressed on disk and it will self-decompress itself at runtime before jumping to the original entry point. On the other hand, the jump to the entry point is even easier to find because it's not encrypted. You will spot it right away. You can see there the PC register will get this value, and this is the address of the original entry point. So this is the start of a compressed file on Pocket PC. There is two main subfunctions. One will uncompress the application in memory, and it will also handle the import table of the application, because you need to resolve every function before you can call them. And then you have another subfunction it's just going to flash the instruction cache so it can call the uncompressed code. So this is an important link part of UPX for Pocket PC. It's very similar to the Windows unpacking routine. It's just a few loops. It just does load library on the GLLs it needs to load, and proc address on the API function it needs to call. So you can easily find out that this subfunction is doing import loading, because you will find calls to those Windows functions, and you will also find constant like the one used to check whether we are importing functions by ordinal or by name. So it's very similar to the Windows UPX. The only difference is the actual assembly language. And exactly like the one on Windows PC, you have a clean image section headers array of structures in memory, so you can have information about the sections prior to compressing. So you have everything like the original section name, the original virtual address of the section, the original size of the section, the write access of the section, if you can be executable, writable, readable, etc. And so you have, this is the first section, the text section. You have the air data section, which is the import table stuff. So you have everything saved in memory. So if you want to dump this application, so you can reverse engineer it, the first thing you need to do is to pause the application on the entry point. So as I said, you have this instruction, which is basically loading this memory location inside the PC register, which is the EIP. And then you can just resume application with F9 inside your debugger. You will stop just before the jump. Then you can single step once more, so you are right at the entry point of the completely unpacked application in memory, and then you can dump it. I will give you a demonstration shortly. So now this other commercial protection, it compresses and encrypts your application. There is like 20 layers of encryption on itself first, and then it will decrypt the application. It has a lot of anti-debugging techniques, and it can also encrypt the resources, so you wouldn't find any strings if you use the string command or anything. Everything is encrypted, and it has many more features, like you can add licensing, like serial numbers to your binary, even if you don't have the code, source code. So this is the disassembly of this protection. It looks very similar to UPX. You have still the same thing, load library and get proc address. So this is very something you need to look at when you are trying to unpack application on Pocket PC, because most of the time they are going to use those functions. Then you will eventually find some loops through every imported functions. In this one, you have first you have a test. This is basically just testing whether we are importing functions by ordinal or by name. And then we just do a get proc address on the function we need to get the address. And with this instruction, the protection is just filling the import address table with the good pointers to functions. So your original application then can eventually call the functions normally. You also have, on this one, you have a different function to flush the cache, but most packers will eventually flush it cache. So this one is using cache range flush. So far I have seen 3 functions used for this flushing stuff. The first one is flush instruction cache. Then we have a cache sync, like UPX is using. And this commercial protection is using cache range flush. So this is a few functions you might want to look at when you are trying to unpack packers for Pocket PC. Okay. It's very small. You have to try to find. I will have to move it because it's too small if I keep a normal resolution. So basically what I'm doing here is just looking through the P files, the PE editor, looking for the entry point and image base and everything. I am looking at the section names, the virtual address, the row size. We can see the row size is here we can see the row size and row offset is 0. This is a good indication that the file has been compressed. And so usually I start looking at the section headers first. I start unpacking files. Then I'm looking at the import table, looking for imported functions. We see a few nice functions. Then there's only a few imported functions, probably just because they want to keep track on which DLL have been used by the original application. And we can see that the resource section has been compressed. You can just get anything from the resource section. Then you open the file in IDA. You need to load everything because you will need to extract the headers from this file. Change the resolution. It's going to be small. So this is the start of the application, and the first thing you need to do is you need to get the headers file, the headers to the file. So I'm using a script I did for dumping everything. I will just give it after the presentation. So you use the script, you dump the headers to disk. Because there is no PE header in memory anyway. Then you need to go back to, well, the script is going to output information about the file, like image base and 3 points and things like this. So then you need to go to the entry point of the application, and you can start debugging it, because we need to first get the decrypted application before you can dump it. So I'm connecting to the Pocket PC. So there we are. I'm just debugging the application. This is the entry point, and I want to put a breakpoint on the jump to the entry point, which is right here. I will put the video online anyway because it's probably very small. So there is two sub-functions, as I said. This is a decompression function of UPX, and you have those two part of code are the one that are going to use get proc address and load library. So you can just keep most of the sub-function because you don't want to trace everything, because you don't need. You just want to get an unpacked application in memory. So I'm just tracing to show how it looks like on Pocket PC, just ARM assembly. So you can use F4 to bypass the loops and everything. And we can see that the application has been decrypted at this point. So now we are just going to have a look at the original application. This is the original entry point. Everything has been decrypted in memory. So I'm just showing how it looks like. There are two sub-functions, one for load library and one for get proc address. If you look at the register state, you can see. Well, there is a pointer to get proc address in one register and a pointer to a load library in another one. So you can just easily find out which sub-function is calling get proc address and which one is calling load library. So you can just rename everything. As you can see, this one had a load library, and the one below will have a get proc address. So you can just rename this location to get a better disassembly. So now you can see you have everything renamed properly. You have a load library, get proc address, and this is just filling the import table with the good pointers. So the original application can just call the function it needs. So you can see in R0 there is a pointer to some function. This is a function that is going to be called by the original application at some point. So just a big loop, getting every function it needs and put them inside the import address table. It's very similar to handling import table on Windows PC. So you can just rename the sub-function to decompress and handle import stuff. Then the next one is a jump to the flush instruction cache function. So prior to jumping to the original application, UPX is going to flush the instruction cache and then jump to the original application. So everything will be flushed and ready to be executed. So you can rename everything if you need for better understanding of the disassembly. So then you want to put a breakpoint on the to the original entry point. So this is the original entry point. Everything has been decompressed. Everything is ready to be executed. So now you want to dump this process to your hard drive. So for this, I'm using my IDC script, which is just a P dumper. So the first thing I ask you is to get the header file, the one we made when we started the analysis. And you can see there is some output telling you about the size of the application in memory, the RVA of the first section, sorry, in memory, and it tells you the file has been dumped and the number of sections to fix. So in this case, 3. So it gives you some information if you want to look at the file manually. So now we have upxdump.exe with everything fixed. You can start looking inside it with IDA. This one is just a simple regedit application because I didn't want to get infected, just in case. But now the file has been completely decrypted, so you can just start IDA and analyze it. Well, I didn't change the entry point, so you need to change the header with a good entry point, but everything is good. You can see there. Yes. This is strings, so everything is ready for analysis now. So you can just manually change the entry point with a P editor, save it, and just disassemble it again. And you get a nice, clean, unpacked application. IDA will find the win main and everything, so the file is ready for analysis. So this was how you can unpack UPX for Pocket PC. And so now I'm going to look at the commercial protection. And you can see, I hope you can see, all the sections have random names. And so you don't know which section is the code section, the data section, or everything. And you can also see that the entry point is starting in the last section because the virtual offset is the same address than the entry point. So the application is starting from the last section. And if you look at the import table, there is only 2 imported functions from core DLL. There is no more resources, only just a few icons. So you need to open it inside IDA again. Just need to load everything again and dump the headers to disk, because you will need them to get a working file. So again, you just need to go to the headers, then use my dumper to extract everything you need to get a working file. So you just save your dump file. Then what you can do with this one is there is a lot of encrypted layers and a lot of anti-debugging tricks. So what I did was, instead of tracing everything and get lost, you could just use compiler signatures to find the original entry point. So what I did was I just let the application run on my Pocket PC until everything had been decrypted in memory. And so I first stop on the entry point of the packed entry point. If you try to go to other sections, you cannot because of the way Pocket PC is working. So anyway, you can just start the application. So at this point, the application has been decrypted in memory. And I need to find the entry point. So what I did was a little find original entry point IDC script, which will just scan for compiler's bytes signatures, and it will just find the entry point, and comment everything, make code so you can have a clean entry point disassembly. So there. So this is the entry point of the protected application. As you can see, I didn't trace anything. I didn't see any anti-debugging tricks. And I could just go the lazy way and using very simple signatures. So then when you have this, you can just dump the process again with my process dumper. So you just take the header file. It's dumping everything. And you have a nice unpacked file. But for this one, you need to fix the import table. So what you can use is the first thing you need to change is the entry point of the application. Then you need to, if you look at the import table, you still only have two functions. So what you need to do is you can open the file with an X editor, and you can look for the string DLL, and you will see two import tables, the one from the original application, and this one is the one from the packer. There's only core DLL, and those are the original imported functions. The guys who made the protection just didn't remove the original import table. So what you can do is just use this one because everything is ready to be used. So if you look at how the import table is made in this file, you can find out that its size is 50 bytes, 50 bytes X. And usually import address table will stop with a lot of zeros. So there is a full line of 0. So you know that it's the end of the import table. So what you can just do now is open your file in a PE editor, just change the import address virtual address, put 50 for its size, save everything. So this is the import table stuff. If you scroll a bit, you have the DLL, imported DLL. And now, if you just look in the file with IDA, you will have everything rebuilt and ready for analysis. And the file is going to work again on your Pocket PC without any limitation. And you can just patch it and reverse engineer it and whatever you need to do. You can see the function name now. Every imports are fine. Everything is identical to the original application pre-your protection. So you have strings and everything has been decrypted. Even the resources, everything is fine, so you can just do whatever you need to do now. I think that's about it. So you can get my dumper to these places. You have the IDC for dumping Pocket PC files, and you have the script to locate compiler signatures. So you can grab them if you need to try some unpacking on Pocket PC. I gave my slides to the Toor2126 guys, so they will probably be online, so you can just get the address from them. So do you have any questions regarding unpacking PE files for Pocket PC? Okay, thanks. I'm sick.
Hey, just a
The scripts are they? I'm kind of curious how to find the offsets. Did you release the code for the IDC scripts? I'm just curious how it works.
I'm just passing the P.
I still haven't met him in person yet. I talk to him on a regular basis, but I haven't got to meet up with him yet.
Have you met him yet?
Not in person. I talk to him pretty much every day.
Even lately? Yeah. Tuesday? Okay. You didn't contact him for a long time?
Yeah, he's a sharp guy. When he asks me a question, I'm like, you don't need to.
Is he still in America right now?
I think he's in North Carolina with his parents. I don't know if he's going back or when he's going back.
He told me that he was going to be back to Germany.
Yeah. But I don't know if he's been getting along real well with the company, so I don't know if he's going back. So it sounds like they're having a difference in opinions and things. How long have you been chatting?
I'm living with his family.
There's a located here?
Where are you living?
I think I'm driving. I'm actually going to swing by LA